So good morning everyone and welcome to this lecture. In this lecture we are going to start with a brand new topic. It's not a brand new topic, it's just part of the things that we have already done, and that is known as relative motion. Now my first question to you is this a new topic, relative motion, or have we done this thing before? Is this a new topic, relative motion, or have we got any idea before? Tell me. Is this a new topic, relative motion? Do you think that this is a new topic that we are going to do? We are going to do relative motion in one dimension. We are also going to see what is relative motion in two dimension. What do you think about relative motion? Is this a new thing that we are doing just now today, or it is something that we have already done before? What do you think, bacha? New thing or old thing? New, old, new. Anyone think that this is something new that we are doing? Well, this is not something new that we are doing. In fact, on the very first day, uh, from the very first day, we have been doing this. As I told you, since I can take you back for the first class, because that will be in a uh, different file altogether. The first thing that we studied about motion was rest and motion are relative terms. Do you remember this? Rest and motion are relative terms. I told you rest and motion are relative terms, and then you asked, sir, what are these relative terms? What do you mean by this relative term? Then I told you that we call them relative terms because they depend on something which is known as reference frame. Do we remember this? Yes or no? Rest and motion depend on reference frame, and that is why I was calling them as relative terms. Now, since we call them relative terms, that actually means that we were doing relative motion. I told you that rest and motion depends on relative term. It depends on from where you are watching it. If you're watching it from somewhere, it might feel like the body is moving. If you're watching it from somewhere else, it might feel like the body is at rest. A body is at rest or body is in motion depends on your reference frame. Up till now, what was happening was we were studying all the motion from ground. Up till now, all the motions that we studied were from ground. So when I said velocity of a bike is 5 meter per second, that was velocity of the bike with respect to ground. When I said a train is moving with a velocity of 10 meter per second, we did not mention with respect to what. It was always with respect to ground, my dear friend. We were doing all these questions, we were taking velocities with respect to ground. Now, sometimes doing a question from ground, reference frame of ground, may not be very easy. It may be difficult. But solving it from some other reference would be easy. For example, if you see a boy playing with a ball in a bus and the bus is moving, or a train and the train is moving, once you are sitting in the train, the motion is very simple. You might be throwing the ball up and the ball will be coming down, ball will be going up, ball will be coming down. The motion is very simple, it's motion in a straight line. But for someone who is outside, someone who is outside sitting on ground and watching the same motion of the ball, for him ball is not going up straight and coming down, ball is following the path of a projectile. The answer is same, but the question looks a lot different. It is because it is tougher to solve it in the ground frame. So sometimes we need to shift our reference frame. And that topic comes under this relative motion. Actually, from day one, we were studying relative motion. Do we understand this? But whatever motion we were studying, they were with respect to ground. Now we are going to study the same motion with respect to some other bodies. For example, we might be finding out displacement of A, B. Now, what do you mean by this? When I write this, what I mean by this is the displacement of A with respect to B. When I say A with respect to B, what do I mean? When I become B, how is A moving? How is the motion of A which B is watching or which B is seeing? Do we understand this? Displacement of A with respect to B can be written as displacement of A with respect to ground. Ground is G minus displacement of B with respect to ground. Sometimes we may not write ground, we may just write it as displacement of A minus displacement of B. Do we understand this? Do we understand what I mean by this? This is how I will write it in the form of vectors. If someone asks me VAB, when I say VAB, what do I mean is velocity of A as seen by B. So how will I get this? Velocity of A with respect to ground minus velocity of B with respect to ground. If I have to find out the acceleration of A with respect to B, how will I find it? Acceleration of A with respect to ground minus acceleration of B with respect to ground. Do we understand this? These are the formulas written in the vector form. Now, we might not be using vectors, we will be using the scalar equation. In that case, we will use sign convention. If this is positive, if this side is positive, this side becomes negative. Do we understand this? So we can use positive and negative for relative velocity, relative acceleration. We can also use vectors for the same thing. I'll give you 2 minutes for you to note it down. Have you noted it down?
Yes, sir. Completed.
Okay. Now you can, I've given you the basic formula. You can also write this formula in terms of relative position. How you can write in terms of relative position. I've given you the formula of displacement. You can also write it in terms of position. So this is how you can write it if you don't want to use vectors. See, what do I mean by relative motion? This is, let us say, the origin. This is point B, this is point A. When I say XA, I mean position of X, position of A with respect to O, origin. XB means position of B with respect to origin. When I say XAB, that means position of A with respect to B, and the formula of position of A with respect to B becomes XA minus XB. Do we understand the concept of relative position? XA is telling us the position of A with respect to O. XB is telling us the position of B with respect to O. XAB is telling us the position of A with respect to B. Do we understand this? Yes or no? Please note it down. I'll give you 1 minute to do this.
Completed, sir.
Everyone has done this, beta. Shall we move on? I see students writing. Shall we move on, beta? Everyone? Okay, everyone is writing. Let me wait for them. Don't have to write everything, beta. Please don't write everything. Just draw the diagram. You don't have to note everything down. I hope you can be smart. And just note down what is important there. Not everything. Just note down the formula, and that is more than enough, beta. I hope you understand this, right? Shall we move ahead? Yes. Okay. Well done. Then, since you have noted this down, remember, simple questions are going to come. So let me give you a simple question, and I hope that you can do this, a simple one. So this is the question, and I'll give you 2 minutes to find this out. This question is given in terms of symbols. See the figure, take positive direction towards right and negative towards left. Find XBA, position of B with respect to A, XCA, XCB, XAB, and XAC. I'll give you 2 minutes to do this. Yes, bacha, we got the answer. Anyone? Anyone got the answer? No one?
First one 4 meters.
Let me see. Okay. XBA, position of B with respect to A. Yes, how do I find it out? First, tell me that. How
B
do
to
I?
A.
Huh? XB minus XA. Yes or no? Position of B minus position of A. Position of B is 4, position of A is 0. So this becomes 4. Everyone got this? Yes or no?
Yes, sir.
Boys in the class, you got this? Okay, what about XCA? What about XCA? Anyone got the answer? No one got the answer for this? Should I wait again? Do I have an answer or should I solve it or should I wait? Tell me, beta. Taking a lot of time. Should I solve it? Okay, it is XC minus XA. Position of C is 10 minus 0. It is plus 10 because we have to give sign also because this is vectors. XCB is position of C minus position of B. C is here, B is here. What is the position of B? Origin is here. 6 minus 4 and the answer is plus 2. Then I find position of A with respect to B. Position of A minus position of B. Position of A is origin minus position of B is 4. So this becomes minus 4. What I see here is position of A with respect to B is minus 4 and position of B with respect to A is plus 4. They are opposite of each other because they have to be opposite of each other. B with respect to A, remember this, please remember this. Position of B with respect to A will always be negative of position of A with respect to B. The last thing is I have to find out position of A with respect to C. So that will be position of A minus position of C, 0. I've done it wrongly. Position of C is not 6, position of C is 10, sorry. 10 minus 4. So I'm sorry, I did not see it. 10 minus 6, it is plus 6. Okay, position of A is 0, position of C is 10. So this answer becomes minus 10. If I look at position of A with respect to C, it is coming as minus 10. If I look at the position of C with respect to A, it is coming as plus 10. Both are opposite. How many of you could do this? Please tell me. Please raise your hands and tell me whether you could do this. No one could do this? Only girls, boys? Boys, were you able to do this? Yes or no? Okay. I'll give you 1 minute to note this down. A good beginning with a good question. So now, since we have done the question of position, let us now move on to the second part, which is velocity of A with respect to B. We already know the formula. The formula is, what is the formula? To find the velocity of A with respect to B, it is velocity of A minus velocity of B. You must take one direction as positive. So one velocity will become positive. One direction would be taken as negative. So one velocity might become negative. Velocity of A minus velocity of B is what we need to do. I hope you can do this. So this is a question, very simple one, and I hope that you are able to do this. Please pay attention and do the question. Remember, time is a liberty that we don't have, a luxury that we don't have. So please do this question. Make the best out of the time that you have. So this is the question. Question number 1. An object A is moving with a velocity of 5 meter per second and B is moving with a velocity of 20 meter per second in the same direction. And what is the direction? It is positive x-axis. You can always take positive x-axis as positive and negative x-axis as negative. So an object A and B both are moving in the same direction, positive x-axis. One is moving with a velocity 5 meter per second. The other one is moving with a velocity of 20 meter per second. Find option A, option B. I'll give you 2 minutes to do this. Please try the question. Trial is important. Answers are not. As it's good that I see all of you trying. That is what we need. Just try, and I'm sure that you can get the answers.
Sir,
Yes, beta.
first one is plus 15. Second one is minus 15.
Plus, first one is plus 15. The second one is minus 15. That is correct. Well done. What about the others in the class? I can see someone. I can see. I can see. I can see. I can see some message in the chat as well. Okay, who is writing this message? I don't know. Which center?
Boys. Chintal.
Chintal Center. Okay. So Chintal Center is okay. I got confused. I really got confused. With who was writing. So anyways, let us go ahead and it's a pretty simple one if you can understand. How are you going to do this? Anyone? How I am going to do this? It's a pretty simple one, right? So I hope that you can see this solution. How do I write this? Velocity of A. Okay, your mic is not working. Great. Velocity of A can be written as plus 5. 5 like this. I have taken this direction as positive. Velocity of B, again with respect to ground, both things I am writing will be written as plus 20. I have to find velocity of A with respect to B. So this is velocity of A minus velocity of B. Velocity of A is plus 5 minus plus 20, and the answer would be minus 15. So velocity of A with respect to B, this one is minus 15. As soon as I get velocity of A with respect to B, I don't have to find velocity of B with respect to A because that is the negative of this. So I can write the answer straight away as plus 15. Yes or no? No, yes.
Yes, sir.
See, relative velocity is so simple. I mean, it is as simple as it gets. Can you do the next one and tell me the answer fatafat so that we can move on in life? Life has to move forward. You can't go backwards in life. That is the irony. This is the next one. Two objects A and B are moving towards each other with velocity 10 and 12 meter respectively. Can I have the answers? I'll give you 2 minutes to do this. Okay, I have the answer. Well done.
Huh? 20. So the first one is 22 meter per second. Second one is minus 22 meter per second.
That is correct. So the good part is that everyone is trying. Wrong answers or right answer, that doesn't matter, beta. You can get any answer, wrong or right. It doesn't matter. What matters is that you are trying, and it's good to see you trying. And that is what I've always. Man, I'll give 1 more minute to the students so that you can try it again. You are getting +2. The answer is not far off. So I think you have done a very simple basic mistake. If you can correct that mistake, I'll give you a minute to correct it. If you can correct that mistake, you will get your correct answer. So can you correct that mistake? What is the mistake that we are making? What is the mistake that we are making? Now, remember the difference between this question and the previous one, my dear friends. In the previous question, both the particles were moving in the same direction. In this question, one is moving like this, the other one is moving in the opposite direction. So, if I call the velocity of this body as +10, if I call the velocity of this body as +10, because it is going like this, I can call the velocity of this body as -12. Do we understand this? Yes or no? Then I can apply the formula. Velocity of A with respect to B is velocity of A minus velocity of B. So +10 minus -12, and the answer will be +22 meter per second. That is the velocity of A with respect to B. If I have to find out the velocity of B with respect to A, if I had to do it, I will find it out velocity of B minus velocity of A. Well, I don't have to do it. As soon as I get this as +22, I will get the other one as -22 meter per second. I hope you all understand this. Yes or no? We all understand this, beta? Girls? Boys? Do we understand this? Well, the other class, was something wrong with the camera, beta? The camera has gone out of focus. Is that on purpose? If that is on purpose, it is good. If that is not on purpose, then it is bad. This is better. I can see you. Well, if there is something that you want to do that you don't want to show on screen, well, you can do it after the class. No? Okay. Chalo. Everyone got this? Yes or no? Everyone got this? Okay. Now there is a small thing that you must do that is known as velocity of separation and velocity of approach. So that is the next heading that we are going to write. Velocity of separation and velocity of approach. Velocity of separation and velocity of approach. What do you mean by velocity of separation and what do you mean by velocity of approach? See, if the separation or the distance between the object, two bodies is decreasing, they are getting closer, they are getting nearer, we call it velocity of approach. That is what you need to remember. If the separation is increasing, we call it velocity of separation. So these are the two velocities that you should understand and remember. Velocity of separation and velocity of approach. You may not use this part. It is not relevant to you. You just have to, we are just going to do velocity of separation and approach in 1D, and that is what you need to remember. If the separation is increasing, it is velocity of separation. If the separation is decreasing, it is known as velocity of approach. Just remember these two terms because they might ask you in terms of these two terms. I'll give you 1 minute to note it down. Okay, have you noted this down, beta? Everyone? Okay.
Yes, sir.
Okay. So here is one question. And remember, it doesn't matter what they're asking. You must just remember what you are supposed to do and you just do the same thing. This is the question that we are dealing with. A particle A is moving with a speed of 10 meters per second towards right, and the particle B is moving with a speed of 12 meter per second towards left. First of all, tell me, are they approaching each other or are they moving away from each other? Will you call it velocity of approach or will you call it velocity of separation? Yes, my dear friends. What will you call it? Velocity of separation or will you call it velocity of approach?
Velocity of approach, sir.
Why you will call it velocity of approach, beta? Because
Separation decreases, sir.
separation decreases, they are coming closer, and that is why we call it velocity of approach. Well done. Now you solve the question and tell me what is the velocity of approach. We'll give you 2 minutes. Simple thing. When they ask you to find out the velocity of separation or they want you to find out the velocity of approach, what you have to do is just find their relative velocity and you are done. Whether you find the relative velocity of 1 with respect to 2 or you find out the relative velocity of 2 with respect to 1, doesn't matter. That velocity will be known as their velocity of separation or velocity of approach without the sign. Sign only tells us the direction. So you may not tell the direction. You may just talk about the magnitude. Everyone understand this? Yes or no? Raise hand will give me more confidence that we are there in the class. Okay, great. Yes, bacha, do we have answers? Yes or no? No, yes.
22.
22 meter per second. Is that your answer that you are giving me?
Sir?
22 is the answer that you are giving me?
Yes, sir.
That is the correct answer. That is the correct answer. Students are also trying to write on the board. Is that so? Are you trying to write the answer on the board? I can't see what you're writing on the board. So if you can write it a bit below, probably I can get this. This is a nice way to communicate. I still can't see it, bacha. But we got the answer. So basically what we got to do is we need to find out velocity of either A with respect to B, or you can find out the velocity of B with respect to A. No matter what you find out, since you know that they are approaching each other, the separation is decreasing, it will be known as velocity of approach. So you can call this as plus 10 because it is going like this. The other one will become minus 12 because it is going like this. Let me find out the velocity of A with respect to B. That will be velocity of A minus velocity of B. So it will be plus 10 minus of minus 12, and you will have plus 22. Plus doesn't matter because they are not asking you the relative velocity. They're only asking you the magnitude of velocity of separation or velocity of approach. And this is the answer that we are looking at. Yes, plus 22. I see it. Well done. That is correct, beta. That is correct. Good. Yes, yes, I see it. Anyone understands this? Yes or no? Let us solve one more question and let's see who does it quicker, the girl side or the boy side. This one. Now, first of all, you will have to tell me whether this is velocity of separation or whether this is velocity of approach. That is the first part. Tell me that first. Is it velocity of separation, my dear friends, or is it velocity of approach? Yes. Are the two bodies getting separated, or are the two bodies approaching each other? Is the separation increasing or is the separation decreasing? Is the separation increasing or is the separation decreasing? Yes, my dear friends, what's happening? Is the separation?
We cannot see the question.
Oh, you cannot see the question? Sorry. I was wandering in some universe, probably. A particle A is moving with a speed of 20 meter per second towards right. Another particle B is moving with a speed of 5 meter per second towards right. Both are moving towards right. Is this separation or is this approach? The screen is not visible, sir. I think it's visible now. Yes or no? Sorry,
Velocity of separation, sir.
the other class is saying it is not visible. Okay. I think it will be visible now, but it should be visible. It has to be visible. One body is moving with 20 meter per second towards right. The other particle B is moving 5 meters. Yes, it is separation or is it approach? Huh?
Approach, sir.
Approach, because the distance
Separation is decreasing.
Yes, well done. So we are getting on the right track. Well done, bacha. But I still need the answer from you. I still need the answer from you, beta. How much is that? If you understand the concept, as you can see, beta, it's very simple once you understand the concept. Yes, bacha, how much?
15 meter per second, sir.
15 meter per second. That is the correct answer. Everyone got this? How many of you got this? Yes, I have everyone saying that we have got this. That is great. That is great because that is the correct answer, my dear friends. How I'm supposed to do this? I need to find out the velocity of A with respect to B, or I need to find out the velocity of B with respect to A. Whatever I do, I'll call this as positive. I also call this as positive. Let me find out. Let me find out. I written solution here. Why? Let me find out velocity of A with respect to B. Velocity of A with respect to B will be velocity of A minus velocity of B plus 20 minus plus 5, and the answer is plus 15. Beta, my screen should be visible. I don't know why it is not visible. Is your screen on? Is the screen on your side, beta? Students are saying that they are not able to see the screen. Anyways, I think the screen should be visible because I am also logged in from the other iPad of mine and I can see my screen. So you should be able to see your screen. In any case, we are done with the class today. In today's class, we have covered the concept of relative velocity. You can see the screen now? Yes or no? You can't see the screen? Okay. There must be something wrong. I had to do one more question, but then only 1 minute is left. I will not do it. I will do that question in the next class, and I hope in the next class your screen works. Everyone understood what we have done in today's class? Velocity of separation, approach, relative distance. We have understood this? Okay, well done. Then we will try to move and try to cover the thing in the next chapter. In the next class, we will try to cover the topic of relative motion. I'll see you in the next class. If you have any doubts, you can come up to me. This question is a simple question. You can't see the screen. So probably when you come tomorrow, I will start with the same question. Okay. Take care, beta, and have a nice day. Bye-bye.
Okay, sir. Bye, sir.
Bye, beta.